Time travel is a fascinating and intriguing concept that has been the subject of science fiction for decades. In recent years, with advancements in quantum mechanics, physicists have explored the possibility of time travel within the framework of this theory. The concept of time travel in quantum mechanics has many fascinating and complex aspects that are still being explored and debated by scientists. In this article, we will explore the quantum mechanics of time travel in detail. We will discuss the principles of quantum mechanics that relate to time travel, the paradoxes that arise when considering time travel, and the current state of research on this topic. This article is intended for those who have a basic understanding of quantum mechanics and are interested in exploring the concept of time travel within this framework. Quantum mechanics and time travel. Quantum mechanics is the theory that governs the behavior of particles at the smallest scales. It describes the behavior of particles such as electrons, protons, and photons, which are the building blocks of matter and light. The principles of quantum mechanics are fundamentally different from those of classical mechanics, which describes the behavior of objects on a larger scale. One of the key principles of quantum mechanics is superposition. Superposition is the idea that particles can exist in multiple states or locations simultaneously. This means that a particle can be in two or more places at once or in different states at the same time. This principle has been demonstrated experimentally and is the basis for many quantum technologies, such as quantum computing. The concept of superposition is also applied to time travel. The idea is that an object or particle can exist in multiple points in time simultaneously. This is known as temporal superposition. Temporal superposition is a fundamental concept in the study of time travel in quantum mechanics. Another important concept in quantum mechanics related to time travel is entanglement. Entanglement occurs when two particles become connected in such a way that their states become dependent on each other, even when separated by large distances. This means that if one particle is measured, the state of the other particle will be immediately affected, regardless of the distance between them. Entanglement has been proposed as a possible mechanism for time travel. The idea is that if two particles are entangled, they could be used to transmit information through time, effectively allowing communication with the past or future. However, the concept of using entanglement for time travel is still highly theoretical and has not been demonstrated experimentally. Time travel paradoxes. When considering the possibility of time travel, several paradoxes arise that challenge the concept. These paradoxes are logical inconsistencies that arise when attempting to reconcile the idea of traveling through time with the laws of physics. The most famous of these paradoxes is the grandfather paradox. The grandfather paradox proposes that if you were to go back in time and kill your own grandfather before he had children, then you would never have been born and therefore would not be able to go back in time to perform the act. This creates a logical contradiction that suggests time travel may not be possible. Another paradox that arises in the context of time travel is the bootstrap paradox. The bootstrap paradox occurs when an object or information is sent back in time and becomes the origin of that object or information. For example, if a scientist were to travel back in time and give a famous composer a piece of music, and that composer were to then use that music as the inspiration for their own work, where did the music originally come from? This creates a logical inconsistency that suggests that the origin of the music is unknown, which challenges the concept of time travel. The state of research on time travel paradoxes is still highly theoretical, and there is no clear solution to these paradoxes. However, some researchers have proposed solutions, such as the multiple universes theory, which suggests that each time travel event creates